Okay, guys, good evening. Hope you guys are all doing well and staying safe. Okay, so just before we get started, so you guys all saw that I put all the WebEx recordings that I've recorded on YouTube. So you guys were all, or anybody that tried to watch those, any problems with watching the YouTube videos? Was everything fine with that? I'm assuming it's easier than trying to convert that WRF format. So everybody saw the videos on YouTube if you need those. Okay, and then everyone saw that I updated your grades for attendance and homework and the midterm, and I also put the midterm solutions on Blackboard. So you should be able to see your updated grades as of the midterm point, and so there's a link to the YouTube page that should have all the videos that I've recorded. And then just to see if you didn't see those already, those are the midterm solutions. You guys did pretty well in the midterm, but in case you wanted to see my solutions, those are there. And so, yeah. Okay, so any general questions on the midterm or anything else before we start today's material? Okay, well again, double check your grades. Let me know if you have any questions. And my solutions are posted, and then all the recordings are available as a video on YouTube, and I'll continue to post the rest of them up there in case you missed something or want to hear something again. Alright, so what we're going to do for today is continue with the different types of markets, and we'll spend more time on the fourth type of market, which is oligopoly. And so last time we did the other three types. We did perfect competition, we did monopoly, and we did monopolistic competition, right? We had a homework assignment on that. And now we'll do the last time that we'll spend a couple chapters on and a couple weeks on, which is oligopoly, and because that's one of the markets that has a lot of interesting things, including the different types of oligopoly models and the game theory aspect that we'll cover next week. Alright, so if you look at the syllabus, we have some things left to do, but we're getting close. We're past the halfway point at least. Alright, and so the chapter 8 homework is due today, and we'll do chapter 9 today, and that'll be next week. Next week, we'll do chapter 10, and that homework will be due the next week, just like normal. And then also you'll note that there's another kind of longer homework that's going to be due on the same day as the final. So on Friday, May 29th, like it says in the syllabus, you can't see the screen? Is that better? Okay, that was weird. Alright, so hopefully, I don't know if you guys were paying attention if you couldn't see anything, but I was just kind of going over the rest of the syllabus. Hold on a second. I have to get back to the Blackboard. Okay, can everybody see the screen now and hear me? Okay, so yeah, my whole web browser closed, so hopefully that doesn't happen again. Alright, so here we're back on looking at the syllabus. All the stuff I had, okay, thank you. So all the stuff I had open closed, so let's look at the syllabus one more time. Alright, so chapter 9 tonight, chapter 10 next time, and then in 2 weeks, we'll do the lesson review. And so notice that, in addition, we have another kind of longer homework to do on the same day as the final. And so the oligopoly homework is going to be another, like, semi-longer homework that we, it's kind of like the one we did for the elasticity. And so it's going to be a modified, it used to be a group project, but I'm modifying it to be a simpler individual assignment. And so once we get through all the oligopoly stuff, I'll have that prepared. And so that should be ready next week. And so after we finish chapter 10, we'll go through what you need to do for the oligopoly homework. It's just a little bit, just a different homework, just a little bit longer, but it'll be due the last day, the same day as the final. And so just like what we had before, you had the elasticity homework and the midterm due. And so on May 29th, you'll have the oligopoly homework and the midterm. And so I'll give you guys it shouldn't be too difficult, just a little bit longer than normal homework. But I'll give that out to you next week. You'll have 2 weeks to do that. And then you'll have the final, week 9, you'll have a week to do that. But both of those will be due last week, and those are the two major things that are due at the end of the term. Okay, so just be aware that we have a few more homeworks, and the oligopoly homework and then the midterm. And so you're way more than halfway done, but you still got a few big things. But you guys have done great at putting things on time, and I'm not really worried about any of that issues. So today, chapter 9, and we'll finish the oligopoly material next week. And I'll also have your oligopoly separate homework that'll be prepared next week, and you'll have 2 weeks to do that. Alright, so yeah, everything on the original syllabus is still good to go. Okay, so let's go ahead and start today's material, which is chapter 9 on oligopoly. And All right, I'm going to open up the older version of the textbook and go back to that document because it got closed. But let's look at the chapter 9 in the older PDF version. Okay, you can open up the chapter 9 PowerPoint. You can also go to chapter 9 section on Blackboard and open up the chapter 9 document. Okay, so let's talk about oligopolies. And so this is the last type of market structure we'll talk about. And we'll spend 2 or 3 weeks on it because it's a little more interesting and there's more types of models that you can look at in problems. So this type of market, oligopoly, there's an optional video that you might have seen in Biz 500B. Alright, so an oligopoly is kind of in between monopolistic competition and monopoly. And so you have a market where it's not a pure monopoly, but there's a few large firms that are competing for their share of the market. And so it's a market structure, which is only a few firms, and each of which is large relative to the total industry. And so what this type of market is it's not as simple as monopoly because there's not just one firm that dictates the whole market, but there's a few big firms, and they have to worry about what the other firms are doing because the few big firms are competing for their share of the market. Okay, and so the kind of the profit maximizing decisions are similar to what we did in the last homework assignment, but now the difference and the interesting thing is they have to be concerned about what their competitor might do. And so if you look at what we did in the last homework assignment, let me just bring up that one. Alright, so this is the one you did last week, and so the kind of the process of how they make decisions is similar in oligopoly, but it's a little more complicated because they have to factor in what their big rivals would do instead. So they'll have similar types of cost structures and demand curves, but depending on the type of model and depending on the type of oligopoly, their behavior or their profit maximizing quantity is going to be dependent and going to be determined by what their competitors do as well. So depending on the the type of oligopoly we introduce, we'll still want to choose output in which MR equals MC, so the similar profit maximizing rule will hold. Okay, but the difference is that the choice is going to be partly determined by what their competitors do and the type of market that we introduce. Okay, so just oligopoly in general are a lot of the firms in like the technology or the tech and like technology companies and electronics. I'll put that here. Okay, so many large electronic firms or tech firms are oligopolies, and so a lot of the you can think of lots of examples, and so one of the major ones that always comes up first is smartphones or cell phones. Okay, so think of a type of market that has few big competitors, but they all have a significant share of the market. And so there's only a few, like Apple and Samsung and a few others, but there's not too many competitors in this really big smartphone market. Another market like game consoles, where you have 3 to 4 major players. I'm not sure if I spelled that right, but you have the PlayStation, you have the whatever the Nintendo version is now, and you always have the Xbox. So you have the PlayStation, whatever, the Xbox. I don't even know what the versions are, and then you have. I think Nintendo still has something relatively new, but those are usually the 3 big ones, and they're all competing for their share of the market. So these are some examples of oligopolies. Okay, so let's introduce a type of model for oligopoly, and let's look at how these firms might make their behavior. All right, so this first one, don't worry about this one, so skip this. All right, so the first type of oligopoly we're going to talk about and do a bunch of examples is the Cornell oligopoly. And so this is a market in which there's a few firms, and they all have kind of equal shares in the market. And so the best way to do the model or the example is just to think of 2 firms, and they both have kind of equal shares of the market. And so there's an example I can think of, and then I have a little more on the Word document. But so Cornell is when there's a few firms, having many customers. Firms produce either differentiated or homogeneous products. And each firm believes it will hold. This is the key here. Each firm believes rivals will hold their output constant if it changes its output, and so they're making a decision based on what the other firms will choose in their output, but they're assuming they're not going to change their output based on their output. So they're kind of interdependent in their output, and they both have kind of equal shares of the market. And so this is a specific type of oligopoly called the Cornell, and we'll look at some examples of this. Okay, so on the Chapter 9 Word document, there's some optional videos. There's one on just the intro to oligopoly. You can look at that if you want. And there's one that explains kind of the Cornell and the Stackelberg, which we'll talk about in a minute, and the different types of oligopoly. So the first one here, and I put a bunch more on the Cornell because this is an important one that we'll talk about. And so this is from your Word document, Chapter 9. Okay, so here's some more on the Cornell. So the Cornell oligopoly doesn't address the issue of prices because the price is set by the market, but their output, they get to choose that. So this type of oligopoly, the firms or oligopolies must decide the quantity of output. Okay, so Cornell oligopoly is when there's a few firms serving the market, and the firms produce either differentiated or homogeneous products. We know that. But each firm believes rivals will hold their output constant if it changes its output and barriers to entry exist. So the short way of saying that is they choose their output based on the rival's output, but their decision is not going to change if they're assuming the rival's not going to quickly change their output based on what they choose. Okay, so managers in a Cornell, they make choices that affect the total output, and they hope their choices don't affect the choices of the competitors. So what we're going to do here in this Cornell oligopoly model is the products on a market must be either the same or segregated, so they're producing the same type of good or service. And this situation where neither company has an incentive to change its output, given the other company is called the Cornell equilibrium. Okay, so I have one example here they propose for a real world example of Cornell is the OPEC countries. And so basically these OPEC countries, they decide how much oil or output they want to produce because the amount of oil produced affects the price in the oil market. So basically they choose output based on what the other countries or OPEC countries are doing, but what they do doesn't affect their rivals' output. So they're interconnected, but they're not going to change based on what the rivals do. Okay, so a little more on Cornell if you click on that link, but I'm just trying to introduce the concept of the Cornell oligopoly. And so I think the best way to think of it is just we're going to use an example of two firms. And if you can think of two firms that are kind of have equal shares of some oligopoly market, then that's the best way to think of it. So maybe so I'm going to put I think maybe the game console market has okay, so you guys might know more about this area than me, but it seems to me that Sony and Microsoft have a pretty equal share of the market. So I think that the PlayStation and the Xbox are pretty equal in terms of what they cost and how many use which. And so would you guys agree with that? Do you think Xbox and PlayStation are pretty equal in terms of market share and price, etc.? Okay, so all right, good. So that's what I think. And so I think if you wanted to look at market share and price and features, they're pretty equal. So both of them have significant shares and importance in the market, but they have to be concerned about what the rivals are going to do because it's what they do affects their rivals' choices. All right, so let's use that example for this type of market. So think of a Cornell oligopoly maybe as Sony and Microsoft in the game console market, where you have the PlayStation and the Xbox that are pretty much equal goods in an oligopoly. Okay, so if we think that's a good example, let's look at some models that model this kind of market behavior. And so let's look at a Cournot example. Or let's set up the Cournot type of oligopoly, the textbook Cournot. And so we're going to develop the best response function. All right, so a best response function or reaction function is a function that defines the profit maximizing level of output for a firm for a given output levels of another firm. So basically, we're still going to do like, normally the firm would choose output at which MR equals MC. And we'll still do that, but that condition will be based on also the output of the other firm. So they're choosing their output at MR equals MC, but it also includes what the other firm would choose as well. All right, so if you scroll down to the Cournot stuff in the textbook, all right, so this little graph, the Cournot reaction function, this shows that each firm's output is connected to what the other firm does. So Q2 is firm 2's output, Q, and Q1 is firm 1's output, and you can see that there's a relationship between the two. So what the other firm chooses with their output, that's going to play a role in what the other firm chooses. But because they're both kind of equal shares of the market, they're going to kind of agree upon a point in which they both pretty much choose the same level of output, and it's determined based on the two reaction functions. Okay, so firm 1's reaction function R1 is firm 1's output based on firm 2's output, and firm 2's reaction function R2 is firm 2's reaction function based on firm 1's output. So they're both going to choose their output based on the other firm's output, but because they kind of split the market, they'll agree upon a point in which they both choose, Q1 and Q2 star, which are pretty much the same thing. Okay, so we're going to do some profit maximizing examples in which both firms choose their output based on the other firm's output as well, and we develop these reaction functions, and then choose the profit maximizing quantity, and then the market sets the price. All right, so we're going to look at the demonstration problem 9.4, and this will set up the basic Cournot oligopoly, and we'll stick with two firms and two competing Cournot oligopolies. And so think of these as like I said, Sony and Microsoft in the game console market, so they both have kind of equal share. Right, so I did demonstration problem 9.4 on the separate Word document. Let's go to that. Okay, so this demonstration 9.4 is we're going to get a demand function, and we're basically going to choose the profit maximizing level of output for both firms by developing their reaction function. And it's similar to what we did with all the other firms last week, but now the only difference is, the major difference is there's two firms, and one firm's output is a function of the other firm's output. Okay, so demonstration problem 9.4, let's suppose the inverse demand function for two Cornell duopolists. That's like saying there's two firms, right? So instead of one firm like monopoly, there's two duopolists. Is given below, and in this example, there's cost is 0, which will just simplify the example, but sometimes we'll have positive costs, but this will make it simple for this one. Okay, so there you see the inverse demand function is a function of both the outputs. So the price is a function of, there's a negative relationship between the quantity of firm 1 and the quantity of firm 2. So normally there's an inverse relationship between price and quantity, which is just the law of demand. And the same thing here, except we have two firms' outputs, where here's the output of firm 1, and then the other one is the output of firm 2. And so the outputs of both firms would, indirectly determine the market price. So we're going to determine, based on this demand function, what each firm should choose for their output, and then we can determine what the price will be based on the firms choosing their output. So the firms both pick their outputs, and by doing that, they indirectly control the price of this market. Okay, so the first part is what is each firm's, part A, based on that demand function, what is each firm's marginal revenue? Okay, so I kind of did it for both firms, but revenue is just price times quantity, right? So price is the demand function, and then it's the quantity of that specific firm. So the revenue of firm 1 is the price, 10 minus Q1 minus Q2 from the demand function times quantity of firm 2 times Q2. Q1. Okay, and then the revenue of firm 2 is the price times Q2. Alright, so it's just normally we did it for one firm, price times quantity, but now we have two firms, so it's just the price times the quantity of that specific firm. Alright, so R1 is P times Q1, and R2 is P times Q2. Alright, then we just multiply by the Q. So this goes to 100 Q1 minus Q1 squared minus Q2 Q1, and R2 is 100 Q2 minus Q2 squared minus Q2 Q1. Okay, we're trying to find the marginal revenue, and that would be the derivative of the revenue function with respect to that firm's output. So MR1 is the derivative of R1 with respect to Q1, right? So how this function changes with Q1, and we get 10 minus 2Q1 minus Q1 because the Q2 is just, 10 minus 2Q1 minus Q2. If you differentiate that with respect to Q1, and you should get the same thing, but with Q2 for MR2. Alright, so if you distribute the Q2 here, you get 10 Q2 minus Q2 squared minus Q1 Q2. Alright, and then for MR2, it's the same symmetry, but if you differentiate that R2 with respect to Q2, you should get 10 minus 2Q2 minus Q1. Alright, so you should be able to set up the revenue function for each of the firms and then differentiate it with respect to that firm's output, and that gives you the MR for each of the firms. Okay, so did you guys see how I got the marginal revenue for each specific term? Okay, so part B is what are the reaction functions for the two terms. And so the reaction function just means you choose the optimal output based on the other term's output as well. Right? So instead of MR equals MC, we now have MR1 equals MC2 for this term's best output. And we now have MR2 equals MC2 for this term's best output. So it's the same process. The only big difference is we have two terms. Okay, so we already got the MR1, which is 10 minus 2Q1 minus 2Q. And then there's, in this simplified example, there's no cost. So if there's no cost, then marginal cost is zero. Normally we're going to have a marginal cost, but this simplifies to zero because there are no costs in this simplified example. So if cost is zero, marginal cost is zero. Okay, then the other term, we just set their MR. 10 minus 2Q2 minus Q1 equal to zero because their marginal costs are also zero. And then all you have to do now is solve for that term's output as a function of the other term's output. So for firm 1, we solve for Q1, and for firm 2, we solve for Q2. Alright, so we're solving for Q1 here. So if we just rearrange with some algebra, we get 2Q1 minus 10. Q1 equals 10 minus Q2. I just move the 2Q1 to one side, and if we do it for the other term, we get 2Q2 equals 10 minus Q1. And if we divide both of the functions by 2, we get Q1 equals 5 minus 1 half Q2. And we get over here, Q2 equals 5 minus 1 half Q1. Alright, so these are the reaction functions. So this one over here is firm 1's reaction function, which shows their output as a function of the other term's output. And this is firm 2's reaction function, which shows firm 2's output as a function of firm 1's output. Okay, so everybody good so far on getting the MRs and then the reaction functions, which are basically just the output based on the other term's output. Okay, good. Alright, so I don't know, it keeps telling me about the Q2 in the error for some, I don't know. We'll have to deal with that. Okay, so we left off here where we developed the two terms of reaction functions. Alright, and then part C is what are the Cornell equilibrium outputs. Okay, and so this part is basically just a little bit of algebra where we have two functions, both with two unknowns, and so if we plug in firm 2's reaction function into firm 1's, and firm 1's reaction function into firm 2's, we can solve both of the equations. We have two equations with two unknowns, and all we have to do is plug in each one into the other, and then solve for the other variable. So let's make firm 1's reaction function as just a function of Q1. Alright, so we have Q1 equals 5 minus 1/2 Q2. Alright, so let's just plug in Q2's reaction function into Q2. Alright, so we have this 5 minus 1/2 Q2. We plug this Q2 right into there. So it becomes Q1 equals 5 minus 1/2 times 5 minus 1/2 Q1. We put this Q2 into this Q2, right? And that becomes a big function that we can just solve for Q1. Okay, so if we simplify, we get Q1 equals 5 minus 5/2 plus 1/4 Q1. And if we subtract 1/4 Q1 from both sides, we get 3/4 Q1 and 5 minus 5/2 is 5/2. Alright, and then if we just multiply both sides by 4/3, we get 4/3 times 5/2. And then that simplifies to 20 over 6. And that just simplifies to 10/3. Alright, so it comes out Q1, the optimal Q1 is 10/3. And we should get the same for the other firm in Cornell oligopoly, but you should double check by putting firm 1's reaction function into Q2. Okay, so here we got firm 2's reaction function is 5 minus 1/2 Q1, but we plugged in Q1 right here. Okay, so this Q1 goes into there. So this comes into there. And then we get a nice big function of just the only variable is Q2, and we can solve for Q2. Alright, so we get Q2 equals 5 minus 5/2 plus 1/4 Q2. And if we bring the 1/4 Q2 to the other side, we get 3/4 Q2 equals 5/2, and multiply both sides by 4/3. It's Q2 equals 4/3 minus 5/2, and then that simplifies to 20 over 6, and it further simplifies to the same thing where Q2 star is also 10/3. Alright, so all we did here was plug in the reaction function of the other firm into that firm's reaction function, and then solve for Q1 in the first one, and then solve for Q2 in firm 2's case. Alright, so in the Cornell model, you should always get the same output for both firms, but you want to double check because this will confirm that you did it correctly. Alright, and then they both, by setting their output, they determine the price that the market will pay for this. So this is basically the output of both firms combined. So if you combine the output of Sony for their PlayStations and Microsoft for their Xbox, then combined, this is what the market will pay for all of the tier 1 game consoles. Okay, part D is what is the equilibrium price, and this is easy now that we have the outputs. Okay, start with that demand function and just plug in Q1 star and Q2 star into the demand function, and then this is the market price. All right, so same thing we did with monopoly and monopolistic competition. The only difference is we have two outputs, not just one. Okay, so here's the demand function, 10 minus Q1 plus Q2, and then we put in 10 minus 10 thirds for Q1 minus 10 thirds for Q2, and we get, if we make these as fractions of 3, we get 30 thirds minus 10 thirds minus 10 thirds, and this comes out to 10 thirds. So everything is 10 thirds. Okay, so normally we'll have a cost function, so we'll have some kind of marginal cost. But other than that, that's the big Cournot model, and we'll do it a few more times. But any questions on what we did here for the Cournot model? Okay, so we're basically, it's similar to what we did with the one firm case in monopoly and monopolistic competition. It just gets a little more algebraic because we have the second firm. But if you stick to the same process and just set up the reaction functions and go from there, you should get the outcomes for this Cournot type. All right, so let's look at, so there's two major, well, there's many different types of models that model oligopolies. And in this chapter, I want to focus on two of them. And so the first one was the Cournot, where you have kind of two oligopolies that have equal shares in the market. And the second one is what's called Stackelberg. So let's go back to the PowerPoint for 1 minute. All right, so Stackelberg oligopoly is another type of oligopoly, but here we kind of have one firm that's bigger, and there's a first mover advantage because they have a bigger control of the market. And so here's a firm, Stackelberg. These are the Cournot and Stackelberg are the last names of the economists who came up with these or coined these models. All right, so just like an oligopoly, there's a few firms having many customers. That's an oligopoly. The firms produce differentiated or homogeneous products like any oligopoly. But the difference here is this. So we have one firm that's a leader, and they choose the output first, right? So they get to go first. And the rival, firm 2, is going to choose their output only after firm 1 gets to go. Or so firm 1 goes first, firm 2 goes second, but firm 1 gets the first mover advantage. So they choose whatever output they want, and then based on that, firm 2 reacts. All right, so a single firm, the leader, chooses output, and so that's a typo, but a single firm, the leader, chooses an output before rivals select their outputs. And then all other firms, the followers, take the leader's output as given, it's already been set by the leader, and then they select their outputs that maximize profit given the leader's output. So Now we have a situation in which the leader goes first. They set whatever output they want, and then the other firms, the followers, have no choice but to choose their output only after firm one goes first. Okay, and just like any oligopoly, there's barriers to entry because it's hard to be one of these big players in an oligopolistic market. All right, so I put a little more on the Stackelberg type of oligopoly, and you can click on a link if you want to read more on that. But this is a Stackelberg type of oligopoly. So there's a company that brings the first decision to increase. I think I typo there. So after the first firm brings their decision, the other firms follow the example of a leader and adjust their outputs to maximize profits. So firm one maximizes profits first, the leader, and then all the other firms respond after and maximize their profits as after firm one goes. Okay, so there's got to be a few firms, there's going to be many customers like an oligopoly. They're going to produce distinguished or similar products, right? And then we'll have to have a single company that goes first, and the other companies go second after the firm chooses their output. Okay, and I think this is a good example here where it says an example, a real world example of possibly a Stackelberg type oligopoly with Microsoft in the software market. So there's other firms that make software, but you can probably see that Microsoft is the biggest firm in the software market and has been for a while. And so really they get to, because of their size of the market and their dominance, they kind of do what they want first. And then if other firms can, they can set their output or choose a profit maximizing choice after Microsoft goes. But I'd say especially in the software market, Microsoft has overwhelming share. Not a monopoly, but a significant share of the oligopoly. Okay, so but although Microsoft can make decisions first, the other firms can react to Microsoft's actions when making their own decisions. All right, but the actions of these firms in turn affect Microsoft. So over time, Microsoft will model their behavior as what the other firms have done, but they still get to go first. Okay, so the Stackelberg market will be a good example where Microsoft in the software market is the leader, and then the other firms are the followers. All right, so I'm just going to put the Microsoft here. All right, so for Stackelberg, a good example is Microsoft is the leader in the software market. They set their output first, and then other firms are the followers. All right, so that doesn't mean that Microsoft gets all the market. They get a majority probably, but there's many other software firms, or not many of them, but there's other software competing firms that can find their unique share in the market. So Microsoft does Microsoft Office and Windows, and so they have a majority of the operating system and the business software, but there's still room for many niche software and operating systems. So, Apple's been able to have the Apple OS operating system, which is a smaller share, but it's still very successful. My voice sounds echoey. I don't know. I don't know if I can't hear it from your side, but I don't know. Is it worse than normal? Okay. Yeah, I think it should be the same as normal. I don't have the best audio system. I mean, I'm just like I wasn't prepared for I don't have a microphone or like a setup, so I'm just kind of like yelling into my computer. So hopefully it sounds okay. But all right. Okay, so that's a good example of a Zuckerberg type oligopoly where we have the software market, Microsoft's a leader, and the other firms are the follower. So we'll look at a two-firm example where we'll assume that Microsoft is the leader and maybe something like Apple is the follower. So we only have two firms to make it easier. So in this example, okay, so for Zuckerberg, let's assume that Microsoft is the leader and Apple is the follower, and this is for the software market only. So this is not for like the smartphone market. It would be a different story because Apple probably would be the leader in that market. But in terms of software and operating systems, I think we'd agree that Microsoft has the biggest share of the market. So let's assume that that's the case for this example. All right, so let's look at an example of this demonstration problem 9.6 on page 287. And so that's this one. Okay, and I did this one in the other separate Word document, so we can look at that. Okay, so does the audio sound any better that you log back on? Okay, well, hopefully it sounds as normal. So let's do demonstration problem 9.6, and here we'll have here's demonstration problem 9.6. Let's suppose the inverse demand function for two firms in a homogeneous product Zuckerberg oligopoly. All right, so we'll have a leader and a follower, and the cost functions are given below. So firm one is going to be the leader, and then firm two is the follower. So in our hypothetical example, let's assume that firm 1 in the software market is Microsoft and firm 2 in the software market is Apple. And here's the demand function. E equals 50 minus Q1 plus Q2. And then the cost function for both firms is T1 is 2Q1 and C2 is 2Q2. So we have some positive costs in this example. Okay, so let me I'm gonna pour some more coffee in that cup. I'll be back in like 30 seconds. Okay, so here we go. Part A, the demonstration problem 9.6 is what is firm 2's reaction function. So we only have to do the reaction function for firm 2 because the only firm that reacts is firm 2. Firm 1 doesn't react, it just goes first. So because it's the leader, it doesn't have a reaction function. Only firm 2, the follower, has a reaction function. Okay, so this is the same thing we did before, where the reaction function of firm 2 is the situation where MR2 equals MC2. So we'll start with firm 2, the follower. So first let's find the revenue for firm 2. Alright, so this is just price times quantity. So revenue for firm 2, R2, is P times Q2. And so it's 50 minus Q1 minus Q2 times Q2. Alright, if we distribute the Q2, we get 50 Q2 minus Q2 squared minus Q1 Q2. And if we differentiate that with respect to Q2, we get MR2. Alright, which is 50 minus 2Q2 minus Q1. Okay, but now we also need the marginal cost because there's positive cost. So it's the cost function. If T2 was given by 2Q2, right? And all you have to do for marginal cost is differentiate this with respect to Q2, and that's just 2. So marginal cost for firm 2 is 2. Alright, so that's MR2, and this is MC2. Alright, and to get the reaction function, you just set MR2 equal to MC2. Alright, so we get 50 minus 2Q2 minus Q2 equals 2, and just solve now. For Q2 as a function of firm 1, so you get firm 1, firm 2, reaction function, so this is what firm 2 would do in response to whatever firm 1 would do. So this is firm 2's reaction function because firm 2 is the follower. Alright, so let's just solve for Q2. Alright, so we get 2Q2 equals 50 minus 2 is 48 minus Q1, and if we divide by 2, we get Q2 equals 24 minus 1 half Q1. This is firm 2's reaction function. Okay, so we don't have to find firm 1's reaction function because firm 1 doesn't react, it goes first. Okay, so part B is what is firm 1's output. Alright, so this is kind of the longest part of this one is you have to define firm 1's profit function plug in firm 1's reaction, or firm 2's reaction function, and then maximize profit for firm 1. Alright, so let's first just define profit for firm 1. So profit is revenue minus cost, right? Okay, and so profit for firm 1 is revenue, which is price times quantity, so 50 minus Q1 minus Q2 times Q1. Okay, this is revenue. That's just price times quantity, and then subtract the cost function, which is just 2Q1. Okay, and if we simplify this, we get 50 Q1 minus Q1 squared minus Q2 Q1 minus 2Q1. Alright, and then if we just combine the 50 Q1 minus 2Q1, we get profit 1 equals 48 Q1 minus Q1 squared minus Q2 Q1. Okay, and now what we're going to do is plug in firm 2's reaction function into firm 1's profit function, and then it'll simplify out a little bit nicer. So we're going to pick this Q2 and plug it into this Q2. Alright, if we do that, we get 48 Q1 minus Q1 squared minus Q1 times, and this is now firm 2's reaction function. 24 minus 1/4 Q1. Now all we're going to do now is simplify this, and we get 48 Q1 minus Q1 squared minus 24 Q1 plus 1/2 Q1 squared, and this will simplify nicely to 24 Q1 minus 1/2 Q1 squared. Okay, so that is firm 1's profit function with including firm 2's reaction function. So let's maximize profit for firm 1. Okay, so now we're going to maximize that by choosing Q1. Alright, and to do that, all you have to do is differentiate the profit function with respect to Q1 and then set it equal to 0, because that's the point at which profit maxes out, like it hits the plateau. Alright, and then that's the situation we should choose firm 1's output, because that's the highest point. Okay, so just differentiate that with respect to Q1 and set it equal to 0 to get the high point. Okay, so the derivative of that function with respect to Q1 is just 24 minus Q1 and set it equal to 0 because we want the high point of the slope. Alright, then it's all you have to do now is solve for Q1, so we get that Q1 star equals 24. Okay, so there's a lot going on in part B to get firm 1's output, but the rest of it's kind of easy. So you guys see everybody see what I did for getting firm 1's output by setting up the profit function and putting in firm 2's reaction function and then maximizing profit? Okay, so let's go to part C. Alright, so part C is what is firm 2's output. Now that we have firm 1's output, this is easy. Just plug in firm 1's output into firm 2's reaction function, because they go second. So firm 1's output is 24. Alright, so just plug that into this reaction function. Okay, start with firm 2's reaction function, which is Q2 equals 24 minus 1 half Q1. Alright, and then just plug in Q1 into this reaction function, and then that's going to be what firm 2 is going to do. This is the best thing they can do, given firm 1 already chose its output. Okay, so if we plug in Q1 equals 24, we get 24 minus 1 half 24, and we get Q2 equals 24 minus 12, and so Q2 star, the leader, is going to choose half the output. And so Q2 star is going to be 12. So basically, the leader gets double the output, and firm 2 gets the rest of it. Okay, so basically, like firm 1 doesn't get they get a majority of the market, so they basically get 2/3 because the leader they get to go first, and then the other third would go to firm 2. Okay, and then the market price is easy, so you have the demand function given. P equals 50 minus Q1 plus Q2, and I'll just plug in the optimal Q1 and Q2 and find what the market would pay for the total output combined. So we get the price equals 50 minus Q1 plus Q2, so price equals 50 minus firm 1's output of 24 minus firm 2's output of 12, and that comes out to price 14 for this Stackelberg market. Okay, so that's the Stackelberg one, and so it's slightly, there's a few more steps because you gotta take firm 2's reaction function and plug it into firm 1's profit, and then maximize profit, but similar to the other one. Okay, so questions on this one, the Stackelberg leader follower example. Alright, so what we do next is, the next slide, let's look at an example where we're going to have the same demand function and the same cost function, but we're going to compare the two types of models. Alright, so we're going to compare the Cornell and the Stackelberg, and you can see the difference between with the same demand function and same cost function, where do the prices and outputs and profits go for each of the firms. So it's a nice way to compare the two types of markets when you have the same identical cost structure and demand structure. All right, so we're going to look at this example here. we're going to compare the two types of Cornell and Stackelberg. And so let's look at this one. I did this on the Word document for chapter 9. All right. So comparing the oligopoly markets, to see how each form of oligopoly affects firms, it's useful to compare the models, compare this chapter in terms of individual firm outputs, prices, and profits for the firms. And so to do this, let's use the same market demand and cost conditions for each of the firms when examining the results of either, Cornell versus Stackelberg. And so the inverse market demand we're going to use, and the cost functions are these. So here's the demand function. So price, the inverse demand function is Q equals 1,000 minus Q1 plus Q2. Okay, and the cost function for any firm is just 4Q. The cost function for firm I is just 4QI. So if there's firm 1, it's 4Q1. If it's firm 2, it's 4Q2. So the cost function is always 4 times whatever the output is of the firm. Okay, so let's take this demand function and this cost structure, and let's do the analysis and compare the results from the Cornell versus the Stackelberg. All right, so this will be the full model comparison of both types. You can see where the prices, the outputs, and the profits lie for comparing the two firms, or two markets. Okay, so here we go. Let's do the Cornell first. All right, so you want to find the revenue, you want to find the marginal revenue and marginal cost condition for both of the firms. So first you got to find the revenue. So revenue for firm 1 is P times Q1, so 1,000 minus Q2 minus Q1, 1,000 minus Q1 minus Q2 times Q1. And for firm 2, R2 is 1,000 minus Q1 minus Q2 times Q2. Okay, and then to simplify, we get R1 equals 1,000 Q1 minus Q1 squared minus Q2 Q1, and we get for R2, 1,000 Q2 minus Q2 squared minus Q1 Q2, and then if we differentiate those, this one with respect to Q1, MR1 is 1,000 minus QQ1 minus Q2, and MR2 is 1,000 minus QQ2 minus Q1. Alright, so we got the MR functions for both terms, and now we need to set MR1 equal to MC1, and MR2 equal to MC2 to find the reaction functions of the two Cornell duopolies. Alright, so MR1 equals MC1, and then MR2 equals MC2. Alright, to find the best output for each term. Okay, MR1 is 1,000 minus 2Q1 minus Q2, and then because the cost is 4Q, alright, so the C1 would be 4Q1, and then the marginal cost of that is just 4. And C2 would be 4Q2, and then if you differentiate that with respect to Q2, it's just 4. So the marginal cost for any term is 4, and so let's plug in 4 for the marginal cost condition. Okay, and then 1,000 for term 2, 1,000 minus 2Q1, 2Q2 minus Q2. Sorry, 1,000 minus 2Q2 minus Q1 equals 4. So these are both the MR equals MC situations for the two terms. And then over here, we're going to solve for Q1. So we get 2Q1 equals 1,000 minus 4 is 996 minus Q2, and over here we get 2Q2 equals 996 minus Q1. And if we solve over here for Q1, we get divide by 2, 498 minus 1 half Q2. And over here we get 498 minus 1 half Q1. So these okay, so those are the reaction functions of the two firms, or firm 1 on the left and firm 2 on the right. Alright, so always double check that the reaction functions in Carnot are similar, because they should be both choosing the same type of reaction based on the other firm's output. So now to find Q1, plug in firm 2's reaction function into firm 1 reaction function. Alright, so we get 498 minus 1 half. This is firm 2's reaction function. 498 minus 1 half Q1. And this is firm 2, we plug in Q1 reaction function into firm 2. So we get Q2 equals 498 minus 1 half times 498 minus 1 half Q2. Alright, so again, this goes into here. And this goes into here. So then we can solve this one for Q1 and this one for Q2. Alright, so let's simplify. We get 498 minus 249 plus 1/4 Q1. And over here we get Q2 equals 498 minus 249 plus 1/4 Q2. Alright, and then subtract 1/4 Q1 from both sides, we get 3/4 Q1. And then 498 minus 249 is 249. And over here we get 3/4 Q2 equals 249. And then just multiply both sides by 4/3. We get Q1 equals 4/3 times 249. And over here we get Q2 equals 4/3 times 249. And if we do this out in the calculator or whatever, it should come out to exactly Q1 star equals 332. And the same thing, Q2 star equals 332. So both the outputs should be the same in the Carnot, because they split the market, and they're both equal to 332. Alright, and then just go back to the demand function and plug in the optimal output to get the market price that this market would dictate the consumer is willing to pay. Alright, so go to the demand function, plug in Q1 star and Q2 star, and we get here's the demand function, 1,000 minus Q1 plus Q2, that was given. And if you plug in 1,000 minus 332 for Q1 and 332 for Q2, we get a actual price P star equals 336. Okay, so last step for the Carnot is to look at the profits, or calculate the profits for the two firms, and they should be the same because they both have the same output and the price is the same. So, the profit of firm 1 is price times quantity minus cost, right? Revenue minus cost. And so P times Q1 minus C1. So profit of firm 1 is price 336 times the output of 332, and then minus 4 times Q1, and Q1 is 332. Okay, so that is the profit calculation of firm one. If you did the calculation in the calculator, you should get that the profit of firm one is 110,224. Okay, then let's do the same for firm two to confirm it's the same profit. Alright, so price times Q2 minus Q2. And price is 336 times the output of 332 minus the cost structure of 4 times 332, and that should come out to the same profit from 2 of 110,224. Okay, so for Cornell, you have to determine them, but you should get the same outputs. You should get the same profits. And the price is determined by how much the market would pay for the level of output that both firms are choosing simultaneously. Okay, so if everyone's good so far, let's use the same demand and cost structure to compare the results here with the Stackelberg type. So this was the Xbox versus PlayStation, where they both kind of split the market. And the Stackelberg is something like the software market, where Microsoft is a leader and Apple might be the follower because they get to go second. Okay, so let's stick with the same demand and cost structure and do the analysis for Stackelberg. Okay, so the good news is we already have firm two's reaction function because we solved for it in the previous analysis. All right, so given the same demand and cost structure, this is going to be firm two's reaction function. All right, so let's stick with that, and that's firm two's reaction function that we already solved for. Okay, so if you didn't solve for it already, you would have to, but it's going to be the same. Where if you set the MR2 equal to MC2, you're going to get this reaction function. Okay, so that's what firm one's going to use is firm two's reaction function. We already have firm two's reaction function from doing the Cornell analysis. Okay, and we also have, we already solved for, or was calculated, firm one's revenue, right, in the previous example. Okay, so we already have R1, which was the revenue of firm one, and we also already have the reaction function of firm two. So let's take those down below and use those again, because we already have those, and we need those for the Stackelberg analysis. Okay, so then I put firm two's reaction function and firm one's revenue, and those are not given, but we already solved for those in the previous part, so I just put them again here because there's no point doing the same math again if we already have that. Okay, so first thing we have to do, we would do for Stackelberg is find firm two's reaction function. We already got that. And then let's set up firm one's profit function to do their profit max profit. Okay, so firm one is going to set up the profit function of revenue minus cost. All right, we already have the revenue function from the previous example, so put that in the right there. And then the cost structure is the same, so cost is always 4Q. Okay, so just subtract the cost of 4Q1. Okay, so there is the revenue from before, and then the cost is 4Q1, so subtract that right here, and then that's revenue minus cost. Alright, so if we simplify, we get 1,000 minus 4 is 996 Q1, minus Q1 squared minus Q2 Q1. And now we have to plug in firm 2's reaction function into this Q2. So we get profit 1 equals 996 Q1 minus Q1 squared minus Q1 times. And for Q2, we plug in firm 2's reaction function. So this goes into there for firm 2 because firm 1 needs to factor in firm 2's reaction function when it's maximizing profit because it knows what firm 2 is going to do based on the cost structure and the demand function. Alright, then distribute the Q1 there, so we get the profit of firm 1 is 996 Q1 minus Q1 squared minus 498 Q1 plus 1 half Q1 squared, and if we simplify the Q1s, we get 996 minus 498, which is 498 Q1, then minus Q1 squared plus 1 half Q1 squared simplifies to negative 1 half Q1 squared. Alright, so it all simplifies to this nice little profit function. So that incorporates firm 2's reaction function into firm 1's profit function. Okay, now let's just maximize profit for firm 1 by choosing the best Q1. So maximize that profit function up here with respect to Q1. Okay, and again, to maximize profit, all you have to do is differentiate the profit function by choosing output, where the derivative equals 0, because that's the point when the profit hits a high peak. So when the change is 0, that's when you reach your highest point. Okay, so differentiate profit with respect to Q1 and set it equal to 0, and then choose Q1. And so profit 1 dQ1 is just 498 minus Q1, and that's set to 0 because we want the Q that chooses the highest profit. And if we solve for Q1 now, we just get Q1 star equals 498. Okay, so we get, that's the output of firm 1, and now firm 2 in this Stackelberg is the follower, so they take that output, put it into their reaction function, and then choose their output based on firm 1's already chosen output. Okay, so let's start with firm 2's reaction function that we already have. 498 minus 1 half Q1, and let's plug in firm 1's output into firm 2's reaction function. So we get 498 minus 1/4. Q1 star is 498. And that gives us 498 minus 1 half 498, which is 249. And 498 minus 249 gives us Q2 star of 249. Okay, so firm 1's output is double again what firm 2's is, which means that firm 1 has 2/3 of the market. Alright, so to find price, just put in Q1 star and Q2 star into the demand function that was given, 1,000 minus Q1 plus Q2. So we get 1,000 minus Q1 star is 498, minus Q2 star is 249, and that gives us the price that these consumers would pay for this Stackelberg good, 253. Alright, so last thing you need to do is determine the profits for each of the firms, and you should know that firm 1's profit is going to be higher because they've got higher output in this market as the leader. Alright, so profit of firm 1 is equal to the price times quantity minus cost, so price times Q1 minus P1. Price is 253. Q1 is 498 minus the cost structure is always 4 times Q here. So 4 times output of 498. And that should, if you put that in the calculator, that simplifies to a profit of firm 1. Of $124,002. Okay, so what about this firm 2? We do the revenue, price times quantity minus their cost. Price is 253. Firm 2's output is 249, and then minus 4 times 249, because that's the cost structure. Alright, so 4 times C. And then if you put this in the calculator, you should simplify it for firm 2. They get a profit. Of $62,000 in a dollar, and I think that's exactly half of what firm 1 got. Right, so firm 2 in Stackelberg, the follower gets to set half the output, which means they get half the profit. Okay, so if you compare the two types, let's look at the outputs. All right, with the same demand function and cost structure, we see that for Cornell, the two outputs were 332. And for here, they were 249 and 498. So the Cornell outputs come in between these two. Right, you can see that. And you can see that the profits do the same thing, where the firm 1 leader makes the highest profit, and the firm 2 follower makes the lowest profit in Stackelberg, and then the Cornells of 110,224 each come in between the profits of the two Stackelberg firms. Okay, and then see which firm offers the highest versus lowest market price. And so the market price for a Stackelberg firm good is 253. Whereas for the Cornell is 336. So the one with the Stackelberg leader could operate at a lower market price than the Cornell price. So we get the Stackelberg leader gets the highest profit and highest quantity of all of them, and the Stackelberg follower gets the lowest profit and quantity of all of them. And then of the two, the Stackelberg gets a lower market price. So in the Stackelberg side, the consumers get a lower price compared to the Cornell. Okay, so that's kind of the full analysis of doing the Stackelberg versus Cornell or vice versa. So any questions on this analysis? So there's one of these, this is pretty much your homework assignment, another example like this. So everybody good on doing this full analysis and comparing the two types of oligopolies? Okay. All right. So this example is, you can look at this. I'll show you the homework in a minute, but you can use this example that I put up there for chapter 9 to do the homework. All right. So well, let me show you the homework in a minute, but next time we'll do some more oligopoly examples. And we did some game theory, I think, in Viz 500B, but we'll do some more examples and incorporate like repeated games, present value, and some multi-stage games. So we'll do that in more oligopoly types next time in chapter 10. You can open up, let's go to chapter 9, this is the wrong section. Okay, chapter 9 homework. All right, so here you go. You're going to compare the Cornell versus Stackelberg, what you just learned, and you're going to have the same. You have this domain function and these cost functions for the two firms. Okay, and so first thing you'll do is do the analysis for Cornell and find both firms' quantities and profits. All right, so the quantity of firm 1 in profit, and firm 2's quantity and profit, and then the market price. And limited in Cornell, they should be the same. And I guess you really have to you have to find the price, the market price, before you can find the profit. So find the reaction functions, find the profit, the output, then find the price, and then find the profits like we did in the example. All right, and then for Stackelberg, firm 1 is the follower, firm 1 is the leader, firm 2 is the follower. Okay, so what you want to do is set up firm 1's profit function and put in firm 2's reaction function. Remember to maximize profit for firm 1 and choose Q1 star, and then find Q2 star by using the reaction function of firm 2. Okay, then you should be able to find the prices, the market price, and the revenue. Alright, so you should get a situation where both firms have the same output and profit in the Cornell. And in the Stackelberg, firm 1 should have a higher output and profit. And then part C is just confirm that which of the four firms makes the highest profit and the lowest. So you should get the same result as we just did in the example from chapter 9, and then which market of the two. as a lower market price, and so you should confirm the same result we just got. Okay, and this is the homework for Chapter 9. That's due next week in the Chapter 9 discussion forum, the same spot you keep putting them in. So you guys have all been really good at turning your homework in. Okay, so next time we'll do Chapter 10, which is Game 3, and then I'm going to give you guys the oligopoly homework. We'll talk about that next time as well. So next week's meeting might be a little bit long. I mean, probably just it'll be the full 2 hours next week for sure, because we have to do the make sure you guys are good on the oligopoly homework. But yeah, shouldn't be too much longer than 2 hours. And yeah, that's what I wanted to do tonight. So everybody good on doing the homework for Chapter 9? Okay, well, if you have any questions, let me know. And again, this video will be posted on the same YouTube channel, probably tomorrow morning, when I get it converted and uploaded. And so you can look at that if you have need to look at the steps again. Oh yeah, so Chapter 9 homework due next week, and that's all we got for tonight. I'll see you guys next week at the same time. We'll finish up the oligopoly stuff and talk about the oligopoly homework. But yeah, so I'll stay on for a few minutes. Everyone's here for attendance, so if you're good at the homework, you're welcome to leave and have a good weekend. And thanks for coming. Please stay safe, and I will see you guys in 1 week from tonight.
Professor?
Yeah,
I have something to inform you.
sure.
Because I have informed you before about in week 2 or week 3 that I'm going to fly back to my country.
Okay.
But that time I'm going to fly back to Thailand. But on that time when I'm at the airport, my country they closed the border, so I cannot fly back to Thailand. So but right now the government open the border, so I can fly back this Sunday.
Okay.
But I will arrive Thailand on Tuesday, Thailand, which is Monday of the United States. So I can join the leftover of the class of week 8, week 9, week 10. It's fine for me. I want to inform you.
Oh, for next week?
The rest of the class I can join. I don't need to be absent.
Oh, okay, great. Yeah, thanks for letting me know.
Okay, sure. Have a good night.
Okay, have a safe trip.
Thank you so much.